So good morning, everybody. I'm Ferzbek Permatov. My ID number is 1222-5277. Today I'm presenting my topic for computer networks. It's actually the topic of networking, and my theme is VPNs. Okay. Virtual private networks, or VPNs. In an age where digital connectivity is paramount, VPNs play a crucial role in ensuring secure and private communication over public networks, such as the internet. Today, we will delve into the world of VPNs, exploring what they are, why they are essential, and how they work. Okay, let's now move into the definition uh, definition of VPNs. Okay. Okay. At its core, a VPN is a technology that extends a private network across a public network, allowing users to securely transmit data as if they were directly connected to the private network. Whenever you are a business looking to safeguard sensitive network information, or an individual concerned about online privacy, VPNs offer a powerful solution to protect your data from prying eyes. So, and what are the purpose and benefits? So why are VPNs used? VPNs serve a multitude of purpose, including enhancing security. By encrypting data traffic, VPNs prevent unauthorized access and interception, safeguarding sensitive information from the cyber threats. Protecting privacy, VPNs anonymize users' online activities by making their IP addresses, shielding them from tracking and surveillance. And that's it for the benefits and introduction part. So let's get to know how VPNs work. VPNs work in this step, and I will explain them step by step. Okay, imagine you are sending a letter to a friend, but you want to make sure nobody can read it except for your friend. You put your letter in a special envelope that only you and your friend have the keys to open. This envelope also has an address on it, just like a regular letters. Now, instead of sending this letter through the regular regular postal service, where everyone could potentially pick inside, you decide to send it through a secret tunnel that only you and your friend know about. The tunnel goes from your house directly to your friend's house by passing the public postal system altogether. In the world of computer, your letter is like the data you want to send securely, and the special envelopes is encryption. A method of scrambling the data so that only authorized parties can unscramble it. The secret tunnel is like VPN tunnel, a secure pathway through which your encrypted data travels from one point to another on the internet. Here's how it works. Okay, here's how it works, step by step. Imagine, okay. Encryption. Before your encryption step, before your data leaves your device, whether it's a computer, smartphone, or tablet, it gets encrypted. This means it's scrambled into an unreadable format using a special code known as a key. The next step is VPN tunnel. Once a once encrypted, your data enters the VPN tunnel. This tunnel is like a private, secure pathway through the internet. It's created using VPN protocols, which are sets of rules for how devices communicate securely over the internet. The next step is transmission. Your encrypted data travels through the VPN tunnel safely, bypassing potential threats uh, and what and droppers on the internet. Decryption. When your data reaches its destination, such as a company server or a website, it goes through a process called decryption. This is where the encrypted data gets unscrambled back into the original form using the same key that was used to encrypt it. The next one is access step. Once decrypted, the data can be accessed and used by the intended recipient, whether it's a company network or a website server or another device. And that's how VPNs work. Now let's get to know about components of VPN. The components of a VPN, virtual private network, include various elements that work together to create and maintain secure connections over the internet. Here are the main components. The first component is VPN client. The VPN client is software installed on the user's device, such as a computer, smartphone, or tablet. It's responsible for initiating the VPN connection and encrypting the data before sending it over the internet. VPN clients are often provided by VPN service providers or integrated into operating systems. The next component is VPN server. The VPN server is a remote server that acts as a gateway for VPN connections. It's responsible for what? It's responsible for authenticating users, decrypting incoming data, and routing traffic to the appropriate destinations. VPN servers can be hosted by organizations internally or provided by third-party VPN service providers. The VPN protocols. They are sets of rules and specifications that govern how VPN clients and servers communicate securely over the internet. And the fourth one is encryption algorithm. Encryption algorithms are used to scramble data before transmission to secure its confidentially. Common encryption algorithms used in VPN include advanced encryption standard or data encryption standard and reverse Shamir Adliman. That's kind of sort of algorithms. And the fifth one is tunneling protocol. Which is which is used to encapsulate data packets within standardized tunneling formats for secure transmission over the internet. The last one is authentication mechanism. Authentication mechanism verifies and identify of the users or devices before allowing them to establish a VPN connection. So that's it. with the components of VPN. Now move on to types of VPN deployments. When it comes to types of VPN deployments, there is IPsec, which is called Internet Protocol Security. It's a short protocol used to secure IP communications by authenticating and encrypting each IP packet of a communication session. It's commonly used in site-to-site site VPNs and remote access VPNs. IPsec operates at the network layer, which is third one of the OSI model, SSL, and its successor TLS are cryptographic protocols used to secure communications over the internet. And the point-to-point tunneling protocol. Point-to-point tunneling protocol is a legacy VPN protocol that creates a secure tunnel between a user's computer and a VPN server. It's known for its simplicity, but is considered less secure compared to other VPN protocols due to vulnerabilities, and also PPT operates at the data link layer to offset OSI model. So moving on. Layer 2 tunneling protocol. Layer 2 tunneling protocol combines features of L2TP security protocol to create a secure VPN tunnels. It provides data confidentiality, integrity, and authentication, and commonly used in site-to-site VPNs and remote access VPNs. And moving on is moving on the next part. Next part, which is so moving on. The next part, which is OpenVPN, is an open source VPN protocol that uses SSL TLS for key exchange and encryption. It's highly configurable and supports various authentication methods and encryption algorithms. OpenVPN is known for its flexibility, security, and cross-platform compatibility. The last one is so the next one, WireGuard, which is of course is a modern VPN protocol designed for simplicity, speed, and security. It aims to be more efficient and easier to audit than traditional VPN protocols like IPC, IPsec, and OpenVPN. WireGuard uses state-of-the-art cryptographic techniques and operates at the network layer of the OSI model. And going on, the next one is Internet Key Exchange version 2. It's a VPN protocol used for secure key exchange and authentication in IPsec-based VPNs. It's known for its quick connection establishment, support for mobility, such as switching between Wi-Fi and mobile networks, and robust security features. And probably the Next, the last one is secure socket tunneling protocol. Uh, it's a VPN protocol developed by Microsoft that uses SSL or TLS for encryption. It's designed to traverse firewalls and proxy servers by encapsulating VPN traffic within the HTTPS protocol. SSTP is commonly used in Windows-based VPN implementations. So we'll move on, and we come to see like real world applications of VPNs. The first example of this is remote access for employees. Mm, Many organizations use VPNs to provide secure remote access to their employees, allowing them to connect to the company's internal network from anywhere in the world. This facility remote work, uh, telecommuting, and access to corporate resources such as files, applications, and databases. Branch office connectivity. VPNs enable secure communication between different branch offices or remote locations of an organization by connecting these sites over the internet. VPNs facilitate data sharing, collaboration, and centralized management of resources without the need to be uh, dedicated leased lines. So, coming on, cloud connectivity. Organizations often use VPNs to establish secure connections between their on-premises networks and cloud infrastructure or services such as public cloud platforms. Example, AWS, Azure, or private cloud environments. This allows for secure data transfer, seamless integration, and hybrid cloud deployments. Coming on, we are seeing another real-world applications of VPNs, secure remote access for partners and contractors. VPNs can be used to provide secure access to external partners, contractors, or vendors who need to collaborate with an organization's internal teams or access specific resources. This ensures that sensitive information remains protected while facilitating external collaboration and partnerships. The next one is secure mobile access. With the proliferation of mobile devices, VPNs play a crucial role in securing mobile connectivity. Mobile VPN solutions allow users to access corporate networks securely from smartphones, tablets, or laptops, regardless of their location or network connection, Wi-Fi, cellular, etc. Geo-spoofing and bypassing content restrictions. Individuals use VPNs to bypass geographic restrictions imposed by websites, streaming services, or online platforms. By connecting to VPN servers in different locations, user can spoof their IP addresses and access content that may be restricted or blocked in their region due to censorship, licensing agreements, or regional restrictions. The next one is public Wi-Fi security. VPNs are often used by individuals to secure their internet connections, especially when accessing public Wi-Fi networks in cafes, airports, or hotels. By encrypting data transmitted over the network. VPNs protect against potential eavesdropping, hacking, or data interception by malicious actors. So mm, that's it with the real world examples of technologies. And coming on, we are gonna um, discuss the challenges we might face using VPNs. So the first challenge we could face using VPNs could be security concerns. While VPNs provide encryption and secure communications, they are not immune to security vulnerabilities. Attackers may exploit weaknesses in these VPN protocols, implementations, or configurations to compromise network security. The next challenge could be complexity and management. Deploying and managing VPN infrastructure can be complex, um, especially in large-scale environments with multiple endpoints, configurations, and um, security policies. Organizations may face challenges in maintaining and updating VPN configurations to address security threats and compliance requirements. Performance and scalability. VPNs can introduce latency and overhead due to encryption and tunneling processes impacting network performance, especially for bandwidth-intensive applications. Scaling VPN deployments to accommodate growing network demands while maintaining performance and reliability can be challenging. Compatibility and interoperability. Ensuring compatibility and interoperability between different VPN solutions, protocols, and vendor implementations can be a challenge, particularly in heterogeneous network environments with diverse hardware and software components. And now we're going to discuss the future trends with VPNs. Zero Trust Network Access, ZTNA, is an emerging security model that shifts away from traditional perimeter-based security towards a more granular identity-centric approach. ZTNA, ZTNA solutions provide secure access to applications and resources based on user identity, device posture, and contextual factors, reducing reliance on VPNs for networking access. Software-defined wide area network, SDVN. SDVN technology enhances network connectivity and agility by leveraging software-defined networking principles to dynamically route traffic over dramatically route traffic over multiple transport technologies, including VPNs. CDVN solutions offer centralized management application where routing and traffic optimization capabilities, improving performance and flexibility. So the next one could be Secure Access Service Edge, SASE. Converges networking and security functions into a cloud-native architecture combining SDVAN capabilities with security services such as secure web gateway, firewall as a service, and cloud access security broker. And it also provides a unified program, a platform for secure connectivity and access control, reducing reliance on traditional VPN architecture. So that's it. with my presentation, and thank you for your attention. You can see see the video on YouTube channel. Thank you very much.